Okay, there we go. Perfect. So I'm not going to write all the other ones. We have 7 other properties. You have them written down somewhere. I'm getting lazy. I don't feel like writing all 7 out. But this is our last property. Exponents. So I'm just going to label this as number 8 because I'm too lazy to write 1 through 7. Once again, the numbers don't really mean anything. It's just more to keep my brain in order. So our last property is, if we have a base raised to an exponent that's a fraction. Oh, come on. Exponents by itself, and you have to add the fraction in. That's okay. There's a way we kind of go back and forth with this one. If we see one form, we can put it in the other form. So that's called exponential form. We can put it into another form called radical form. A radical looks like a root, like we've seen the square root symbol before. But here's how you write it. Your base goes underneath. Your top, the numerator from that exponent, is going to stay as the exponent to that base. And then the big thing is the bottom goes to the outside of the root. Yes, sir.
Oh, wait, I just forgot. I forgot what I was going to ask.
Okay, if you remember, you just yell it out. Okay, so I'm just going to make a little note to myself, just as a reminder. The top is the exponent. The bottom, we say, is the root. It goes on the outside of that. We call it radical form. So our first part, we're just like going to kind of get used to like, what the heck? Just going in between the forms, because it's one of those things, it's just a little different. So we just want to get used to that. We will be using our calculator for a few things, like if I say, what's something to the, I don't know, 1/5 power? I don't know that, so we might need to use our calculator. That's why it's going to be important to have that handy. And we'll go from there. So here's what some examples will look like. These are more just like the basics, just like getting used to this form type examples. I'm going to say, write in radical form. So I'll just also tell you over here, this is called exponential form because it's an exponent. And this is called radical form. So we do a lot with radicals as we move on in the year. They're all sorts of fun. We use square roots a lot, but you can have cube roots and 4th roots and 27th roots and all sorts of fun stuff. I just need my calculator to make sure my numbers are nice. So write in radical form. If I said I had x to the 5/6. So we're starting basic just to get used to it, because this one is a little bit like, just a little different. And that always sometimes scares me. So it's really just used to going from one of these forms to the other, and we'll go backwards in a second. So just as a reminder, if I said write this in radical form, you would draw the radical, which just looks like a square root symbol. You would say my base is x, and my base is going to go underneath that radical. The top is going to stay as the exponent of that base. And then once again, the bottom is the root. So that's what your answer will look like. That's it. We'll keep it basic to start. This is one of those random things that kind of always pops up, so it's good to know. Oh, yes.
So for this paper, are we turning this in today?
You're just going to upload it to Google Classroom.
Oh, okay.
Okay, so just anytime today.
Okay.
Because if not, I just need everything in one spot, or else I get all sorts of, my brain gets crazy. All right, so still just getting used to this form, going back and forth. What if I said, what's y to the 3/7? Can you guys write that in radical form, following the things we were just doing? Once again, I'm changing a few things, but the setup's the same, so it's just where does everything go? All right, right, so it should be quick, because we're actually not really doing much, we're just rewriting it, right? So when it says radical form, you need a radical. Base goes underneath, top is the exponent, bottom is the root. Any questions about just kind of the general way we write stuff? Once again, I'm just getting to. Ooh, how about this one? We gotta make it fancy, guys. What if I said x to the 3/4, y to the 1/4? Now, what's gonna happen is when you have a whole bunch of bases, you don't wanna have a million radicals. It looks all sorts of ugly. So you don't even want 2 radicals. Well, yeah. So when you write the answer, you just want 1 radical. So what you just need to make sure is, since the denominator is the root that goes on the outside, you just need to make sure that these are the same. That's it. So if they don't have a common denominator, you would make one. But in our case, we're good. Since the denominators are the same, we can put them under the same root. So what I would do is take the base, the top is the exponent, the bottom is the root, so I'm going to put a 4 out there. And then since this one also has the denominator of 4, the root's already there, so we're good. So we would just write it as y to the 1st. And that's how you would write it. So you don't need to write them as separate radicals. And even if they didn't have the same denominator, you would just make them the same. You would just make them have a common denominator. And then you could put them together, and then it would be beautiful. But please, if I say write in radical form, you don't want all separate radicals. You just want one. All right, so that's just kind of getting used to that form. Any questions at the current moment? Okay, so the next one is when we're going to need the calculator, so I'll show it to you in a second. We're going to do the opposite way. I'm going to give you a radical. We're going to write it in exponential form. Once again, just kind of getting used to it. Okay, so let's start with just a basic one, then we'll kind of work our way up. What am I starting with, a radical? So we're just basically doing the opposite of what we just did. We're basically starting on this side of the rule, and we want to write it in this side. Okay, that's fine, we can go either way. So, just as a reminder, your base is a, because that's the only base we see. The exponent stays up there, and the big thing, whatever is out here is the root. You just make it a fraction and put it over that number. So this is really just about just knowing where things go in those forms. Once you kind of get it, it's like, oh, it's always going to go in the same spot, so that's not bad. All right, so let's look at one that has more than one base. So let's say we're going to say something to the 6th root, and we have x to the 5th, y to the 3rd, z. And we're saying, okay, well, they're all under the same root, but we want to write them all as exponents. Okay, so let's just go through. We would say, take each individual base. So we have x to the 5th, and then each of these is now going to become a fraction over 6. Okay, then we're just going to do the same thing. Y to the 3rd, but I'm going to put it over 6. Z to the 1st over 6. Okay, so you can kind of see the pattern, and they just all become fractions over 6.
Would you simplify?
I thought you were a step ahead of me. Thank you. No, I like it. You would simplify your answer. So when we say simplify, if you can reduce one of these fractions, do so. So we would actually write this as x to the 5/6, y to the 1/2, z to the 1/6. That's how you would write your final answer. So then once again, if you had to put it back, you would just make sure they had a common denominator, and you could do it the other way. But we want to make sure, math. We like to make things simplified and beautiful. Okay, so here's where the calculator is going to come in. I'm just giving people a second because I want to erase this. Sometimes we have numbers under radicals, and we I don't know if I have a 5th root of something to the, I don't even know. All sorts of crazy stuff can happen. And we don't want to do that stuff in our head, so this is where calculators are our friends. So let me kind of show you where it's going to come in handy. I'm just trying to come up with nice numbers for you guys. So we have the third root of 343 x to the 5th. And I would say, hey, write that in exponential form. You're like, dude, what do I do with the 343? So I'm going to show you. And then I'll show you how to use your calculator or something like that. So what you're going to do is when you write this in exponential form, you need to make sure that each base has an exponent. So x is to the 5th. Even the 343 needs an exponent, so I'm going to put a 1 there. Okay? Everything needs an exponent. With the base, you throw a 1 there if there's nothing there. So then we would rewrite this, because remember, now we're going to write them as fractions. It would be 343 is to the 1st, but now I'm going to put it over 3. And then x to the 5th, and that would go over 3 as well, since we're under the third root. So this is where we need to know how to do exponents. And then sometimes just calculators can get funky, so try to actually use your calculator and see if we're getting the right answer, because if not, I can help you. And if you don't have one, I got one, then I can help you. But I can tell you, your calculator is going to be your friend for not only the rest of the section, but the rest of the year, / the rest of your life. Right, guys? Okay, so I grabbed my calculator. Let me see, how am I going to project the calculator up? Give me a second. I just want to kind of show you the different buttons that are going to be your friend. I think we've done the exponent button, so you should kind of know that one. But we also have just the how to put fractions in. And sometimes you're like, I'll just do it as like divided by, which is great, but sometimes it's going to get kind of annoying. So, and in a minute, you're going to really see why it's going to be your friend. Okay, so what do I need? Sorry, I need my cover cam. Cha-cha-cha. And then I'm going to share this with you guys. It's going so hard. Yeah. So I have this calculator. I'm going to be honest, it's like a cheap one that the school bought. It's called the CalPal. Super cool. A lot of the ones you'll get at the store, I've never even seen these in stores. I think they're ones that you get at like a warehouse. A lot of the ones at the stores, a lot of people have the TI something X2S, blah, 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 blah. There's other ones. So if you need individual help with your calculator, please let me know. But a lot of them, the buttons are the same. They might just be in a different place. So you're just going to kind of look for them. So I want to plug in 343 to the 130. So in the calculator, first thing I'm going to put is 343. Okay, magical. So I put the base, whatever your base is. Then you find your exponent button. In this case, this one, we call it the caret button. I don't know why. I always need to look it up. It looks like it's raising something, so that means raised to a power. Some of your calculators might have a button that actually looks like an exponent. Use that. So I wish there was just like one calculator somewhere. Oh, look, I have this one too. Look at me with my 2 calcs. So on this one, it's 343. But oh no, this one has a caret too, never mind. But it looks like a fraction, or it looks like an exponent. Now I want to raise it to the 1/3 power. So you have 2 options. If you're going to do like divided by, you need to make sure you put it in parentheses. So you can do parentheses 1 divided by 3. I'm going to be honest, I usually don't do that, but it will work. Let me show you the other way. Hold on, how do I do No, I'm not used to this calculator. Okay. So the other way you can do it, and this way is going to be your friend, you are going to find the button on your calculator. On this calculator, it looks like this. It looks like ABC with a little fraction-y thing. That's going to give you a fraction, magical. On this one, it just looks like a fraction. Once again, magical. So either one, it kind of looks fraction-like. So what happens is if I want to put 1/3 in, I do 1, and I hit that fraction button, 3. And what that little backwards L-y thing means is it just means 1/3. It's just a fancy way to write it. You don't need parentheses this way unless you want to put them in, but go for it. So what this is saying is 343. That means I'm raising it to the power and that means 1/3, 1/3. Once again, I get that by doing this button. If I'm doing it on this one, I just do 1, and I hit the fraction button, 3, and that one just looks like a fraction, it's just the difference between the two. If I hit enter, oh no, okay, I lied to you guys. The answer should be 7, I guess I do need parentheses. Well done, you go away. Let me throw parentheses in here. Usually I don't, maybe mine just stinks, you can try without. Okay, it should be 7. So I guess I found out the hard way. On this calculator, I need parentheses, on this I don't. So it's just your calculator. Can everyone right now try to plug in 343 raised to the 1/3 and make sure you do get 7 as an answer? If you don't, try parentheses around your fraction. Sometimes, as we just saw, it didn't work with my first one, but it worked with the second one. And then once again, it's just like, why can't they make one calculator? Like, come on. Everyone has different ones. It's just kind of annoying. But if you need specific calculator help, please let me know. But being able to do this will be helpful to you in a few minutes when I'm asking you to do all sorts of crazy numbers. Under radicals, you can make it an exponent and then use your calculator. But once again, on this one, or if you have the TI, X2S, whatever it is, this ABC button is going to be your friend, okay? In a few minutes when we're doing all sorts of fraction stuff. On this one, it just looks like a fraction. It will be your friend. It will do things like reduce fractions, add them, subtract them, multiply them. It'll do common denominators. It'll do basically everything for you, which is the nice part. You just need to know how to use it. So I'll give you some more tutorials on that in a second. But let's try 1 or 2 where you're going to have to use your calculator to find some values. Once again, I'll try to give values like semi-decent. I'm not going to give you weird ones. So if you get a weird answer, something went wrong with how you plugged it in. So right now, we'll do this one together and then I'm going to have you try one. If I said, I need the 6th root of 262,144, A to the 9th, B to the 7th. We don't get freaked out by big numbers because you don't even have to do it in your head anyways. The big thing is, do I know how to use my calculator? So, I know sometimes we're like, don't use them, like use your brain. But this stuff you would never do in your head, so use them. Make sure everything has an exponent. B is good, A is good, 262,144 I'm going to raise to the 1st power. Just as a reminder, because for each base, I keep the base, I keep the exponents, and then each of them are going to be over 6 now. Okay, and then once again, I have no clue what this is. So I'm going to grab my calculator, you grab yours. Put in 262,144, raise it, and then put in 16. You might want parentheses around the 16. I'm going to definitely put them and see what you get. Can someone tell me what did they get?
8.
It should be 8. So if you're not getting 8, then you don't know what you're doing, or your calculator's weird, or it's just something's funky. Let me know. As I'm writing my final answer, we do reduce fractions as we see them. So that would be 3/2 and then 7/6. That's how you do your final. So I'm going to have you guys try the next one. So if I said write something in exponential form, could you take the radical, make it into the exponents, and then if you see a number base, could you simplify it? All right, here's number 4. Number 5. Let's do, sorry, I'm using my calculator so I don't give you weird, crazy numbers that don't make sense. Let's do the 4th root of 6561, x to the 8th, y, z to the 5th. can you please write that in exponential form? And if you have a number base, can you please simplify it? AKA, use your calculator. You're never gonna have to do that in your head, but that means you need a calculator with you, so. Just as a heads up. Give me another minute. When something's new, it's like, hey, you still gotta play with it a little bit, so see that you're okay.
Alright, so let's take a look at this, folks. Suppose the just given their written on a step up with their explanatory, with their use of response, and click to which one is going to explain the other?
Oh, perfect timing, sweet stuff. A few other quick things to do, and most of them are on the calculator, so you're gonna like the next part. Even though it's gonna look annoying, help is your friend. We'll just try it here, and that's it. All right, let's check this one though, because if we're good with this, we're gonna kind of move on. If you have questions, I'm happy to answer them. You just gotta ask them. First thing I do, I always start by like just checking, does everything have an exponent? If it doesn't, I put a 1, because right, we assume the 1 is there. So even the number base, raise it to the first, and just make sure everything has that exponent, because everything's now going to become a fraction over 4. So we have 65, 61 to the 1 over 4, x to the 8 over 4, y to the 1 over 4, a z to the 5 over 4. Delightful. I grab my calculator. 65, 61 raised to the 1/4 power. Just make sure whatever works in your calculator, do that. It should come out to 9. So I'll try to make them like nice numbers. You're never going to get like a weird decimal. Should be a nice integer. And I just look, is there anything else I can kind of simplify? Well, 8 over 4 is just x squared. And then all the other ones would just kind of stay. And that, my friends, 9x squared y to the 1/4 z to the 5/4 would be your final answer. Well, can you please do a quick check of that? Does anyone right now have a question with how to go back and forth between radical form and exponential form? For the y or for the 65, 61? So everything technically has an exponent. So like the z, we wrote the 5, the x, we wrote the 8. If you just have a base and there's no exponent, we assume there's a 1 there. So it's even for the number. If you just ever have a number written, technically there is an exponent of 1. So if you ever see a base and it's just like chilling by itself, you always put an exponent of 1. It's just kind of a filler because you need the exponent, because then when you write it in radical form, you need something on the top. So if you don't see something, you assume there's a 1 there. So even for, I know that freaks people out with the number. That's okay. It's still raised to the first power. That just is itself. So if you ever see something without an exponent, the exponent is 1. Then you put it over 4. That's 4 to 3. Okay. Now for the fun stuff. Or are there any other questions? Sorry, I got excited. Okay, now for the fun stuff. Using our other properties, combining stuff with fractions, and then writing them in different forms. So let's say I said simplify the following. And I'm going to say write your answer in radical form. Sorry, I just want to make nice numbers for you guys. I don't want to make anything too crazy, you know. Well, actually, so x to the 1/3 times x to the 5/9 times x to the 7/8. So what's happening is we have all these bases of x. Okay, great. So I can combine them. I have properties 1 through 7. I didn't rewrite them, but we should be getting used to them. And we remind ourselves that if I see multiplication with the same base, I can add all of these fractions. I'm with you. I do not want to add these in my head. Like, that seems like torture. Just the common denominator alone is going to be annoying. So I'm going to use my calculator. So I'm going to show you just some stuff with fractions again, just because sometimes answers can come up a little weird. But once again, we're not going to have a heart attack when we see fractions. We're going to use our calculator to combine everything. Don't put in radical form till the end. So don't start putting in radical form now. That's just messy. Yeah. So let me throw out my calculator again so I can show you what we're going to do. Hold on, I just need to write those numbers down. 1/3, 5/9, and 7/8. Okay. Oh, good. Oh, that comes out beautiful. Okay. So I'm just going to show you once again because, let's be honest, I know some of you have a phobia of fractions. You discriminate against them. They anger you. So if you know how to do them in your calculator, think about how much easier your life is going to be. So I'm putting both of mine just so if you have one similar. I think most of them have kind of this setup. You see them. Let me just throw it up for the people here so they can see as well. All right, so we go into the problem, we said, okay, they're connected with multiplication. We wanted to add those 3 fractions. So here's how you do it. I'll start with this one, then I'll do it on both of them. My first fraction was 1/3. So I'm literally gonna do 1. I'm gonna hit that ABC fraction button, and then I'm gonna put 3. So that represents the fraction 1/3, okay? And then our rule was we're gonna add, so I'm gonna do plus. The next fraction was 5/9. So I do 5, I hit my ABC because that makes it a fraction, 9. And then the third fraction was 7/8. So that's plus 7, fraction button 8. So I can see right now I'm adding my 3 fractions. I'm going to do the same thing over here. 1/3. Just make sure if you're doing this one, like you get out of the fractions and do the plus. Plus 5/9 plus 7/8. Okay, so we have both of our setups. I press equal. Don't look at that one yet. That will give me the nice answer. Okay, so what this means, when you're looking at that, you're like, what the heck is happening? That means the answer 1 and 55/72. So if it has 3 things, it means it's a mixed number. It means that's the whole number. And then you have this other fraction. We don't want mixed numbers. Mixed numbers are stink. So if you ever want to change a mixed number to an improper fraction, which is what we want, you're going to hit shift or seconds. It depends on your calculator or whatever. Shift, seconds. I don't know if anything else. And then hit that ABC fraction button again. And it should give it to you as an improper fraction. So my answer, when I add 1/3 plus 5/9 plus 7/8, instead of the torture of having to do common denominators and all that fun stuff, we throw it in our calculator. It's just knowing how to get it into the answer that we want. If you do have an improper fraction, you just hit second and then the ABC button again. And my final answer for my exponent will be 127/72. And that one just gave me 127/72. And that's that. So this is your friend. From now on, you should never say, oh, fraction. You should literally be like, oh, I know how to throw it in my calculator. You can always use a calculator in here. So you should be in better shape, not be so judgy of them. I'm going from there. So once again, this is the ABC button on this one, or if you just have a fraction button, go with it. So you put them in, press enter. If you see a mixed number, if you see like 3 parts, you just hit second and then the ABC button again. We have our nice improper fraction. So let's actually write the answer and make sure we can then put that in radical form. But from now on, if you haven't, I just showed you kind of the details. If you're having an issue with your calculator, please let me know. So like you can share your screen, you can show me what you're doing. But don't sit there and not know how to use it because it's just silly. And I've seen most of the calculators at some point, so I can probably help you with it. You just need to ask. Okay, so let's go back on computer, to the board and just write our answer.